Alrighty, we might jump on in. So good afternoon, everyone, and welcome to Trust for Nature's Managing Pests, What to Do and What Not to Do webinar. My name is Shay Brennan, and I'll be hosting today's session. I would like to begin by acknowledging the traditional owners of the land in which we all join in from today and pay my respects to their elders past, present and emerging. I would also like to extend my thanks to any Aboriginal or Torres Strait people in attendance today. Feel free to pop into the chat box the land in which you're joining in from today. Now for some housekeeping. We're aiming to finish today's session at 1:30 with the webinar currently being recorded. This recording will be available at a later date on Trust for Nature's YouTube site. There will be question time at the end of today's session, so if you have any questions throughout, feel free to pop these into the Q&A box, which is located at the base of your screen. A little about Trust for Nature. Trust for Nature is a not-for-profit organisation that has been working with willing private landholders to permanently protect important habitat across Victoria since 1972. Thanks to Bushfire Recovery Victoria, Trust for Nature has the opportunity to bring you all 4 experts in the field of pest animal management to provide us all with information on what we can do to protect our natural environment. Without further ado, let's get stuck into the presentations. I would like to welcome Brett Mills from Trust for Nature. Brett has over 20 years experience with private land management with a recent focus on deer control, which Brett will discuss with us today. Brett, over to you.
Thanks, Shay. I might just start with sharing my screen and starting. Hope everyone can see that. Look, my talk today will be about deer control on protected private land. But before I start, I'll just add to what Shay said. I'd like to acknowledge the traditional owners, particularly of our area here in East Gippsland, the 5 clans of the Gunai-Kurnai Nation. Yep. So, and adding to what Shay said about Trust for Nature, it is important to know a little bit about it because we're a big footprint over most of Victoria now, a very popular project and organisation. Trust for Nature helps landholders permanently protect their bush through a conservation covenant on title. This slide here is of a fire affected covenant where we're undertaking deer control. There are 2 main approaches for deer control. Both approaches are important. First is on public land, and it's via a broad landscape approach. And secondly, on private land, it's a more of a targeted individual approach. The main goal is to support the regeneration process after fires. And of course, in the private land, it's our landholders. 43 covenants were affected by the fires in our north and east during the 2019-2020 fires. Again, our goal is to look after our landholders and the regeneration of the bush they protect. We also work with adjoining landholders and linking properties to maximise this outcome. And this photo here shows one of our covenanters, Max James, up in Wongrabel on the Genoa River. And that's on his covenanted property just after the fires. Things were still burning.
Sorry, Brett, just to jump in there, mate. We're seeing both of your slides. Could we just see the main presentation, please?
Sure, I might stop and share screen again. That's interesting, isn't it? So that one.
Technology, hey?
Yeah, okay. How about that?
Perfect. Thanks, mate.
Good on you. Thanks, Shay. I must thank Tess and Amelia and Kat. They've been wonderful trying to help me sort this out too. So I'm a bit of a dinosaur when it comes to PowerPoints. So the sambar deer is primarily the target species for the program. For private land, it's the understanding of their behaviour and ecology, and this is a critical resource to optimise the effectiveness of a control program. This is known as profiling. One source of information is from the game cameras, and this helps support estimating deer numbers and, importantly, their social dynamics. In this couple of slides here, just two photos. The first slide on the left is a mature sambar stag in velvet, and he's actually subordinate to the smaller hard antler stag on the right. This little hard antler stag is actively breeding with an in-season hind. You can tell by the lip curl, which is called flamen, for those who are interested. And out the back is a small spiker in a wallow, which is keeping his distance, but keeping quite observant of what's happening. So a lot of information can come from just two photos, and that really helps set up how we approach a property. Sambar deer impacts the long-term survival of plants, and the process of recruitment is complex. For example, rainfall events, weather, other browsers, weeds, etc., all play their part. The end game can change dramatically with just one adjustment, such as the removal of sambar at a critical stage after fire. This could make a huge difference to the long-term survival of some species. And you can see in this slide, there's a hind, which is a female sambar deer. A hind has just come through a creek, and she's trotted across through some wet ash and left lots of drops from her body in the wet ash. Look, we are working in burnt and unburnt areas. You might think that's a bit interesting, but unburnt areas can become a refuge for all flora and fauna post-fire. The initial deer control program works on protecting young plants directly after the fire in both settings. The medium and long-term control phases assist surviving and regenerating adolescent plants into maturity. Refuges can lose adults as well as young plants through overbrowsing throughout all stages of time following fire. And of these couple of photos here, the one on the left is just a fern coming up after fire. The middle one is a tree that's trying to coppice after being burnt, and a sambar deer has rubbed the coppice branches of it. And the third right photo is of a refuge area, and you can see it's heavily browsed. The sweet potostrum down the back has got quite a distinct browse line, and just about everything green and leafy below that's been eaten out by sambar. So look, I undertake deer population assessments at each site, which forms the basis of an operation plan that optimises the most efficient and effective removal program for each property. This on-ground evidence is often cross-checked with camera information to build a picture of deer population and their behaviour. This goes towards a works program for the removal of the deer. And look, these number of photos here are all interesting. On the bottom left corner, there's a stag that's been in quite a hurry to get away. You can tell an awful lot from the footprints. You can understand the different age sets of deer, the different sexes of the deer, and their behaviour, what they're up to, whether they're feeding, socialising, travelling, and a whole bunch of information can be gathered by just watching footprints. Just above that, there's a preaching tree or rut stand, which stags socially mark. And up the top left corner, there's a rub tree with 6 months of coppice. So that tells me a story about hard antler stags in the area and who's been rubbing that. There's bedding areas up in the top there, which tells me how many animals are bedding and the social group dynamics in that site and why they've bedded there, and potentially where they're travelling. Other rub trees. And again, look, droppings, they can make a huge difference. I can understand the age set of all the deer, the sexes of the deer, where they're eating, where they're bedding, and where they're travelling from scats and where they're found. Wallows are in the bottom corner down there, and that's just another social meeting point, and it's a terrific spot to put a game camera, because every deer within that area will meet at that social place, and that it really helps profile the site. And I couldn't help but put on that rubbed pine post there. That was on a shed on a property that we're doing deer control. The stag had taken quite a liking to this pine post and nearly rubbed it completely through. We've been working on basically 5 main areas in East Gippsland. The first area is the Lakes unit. There's a number of properties there. Second is the Cassilis and Riley Creek unit. Again, a number of properties there. And the Bindi unit, just 1 or 2 main properties there. The Marlow unit, Marlow Plains unit, we've got about 8 properties that we're dealing with there. And the Wongarabel unit, which is the Upper Genoa River unit. There's at least 3 properties there that we work on. There is challenges with working with private land. Generally, they are small patches of land. Governor and council orders have to be sourced. Project authorisations, specialist contractors, they all have to be sourced. They all have restricted areas and times available for deer control. For example, holidays, neighbours, police, weather conditions, contractor availability, all have to be costed in before anything can start. So yes, look, facilitation goes hands in hand to help coordinate all partners to run a successful program. All of our covenanters, such as Rob and Virginia in the Wongarabel Valley, they're the first slide, have been very supportive of the program. In the middle slide, second slide, myself is facilitating a program with agency staff and contractors. And the third slide is Tess and Amelia, our Trust for Nature conservation officers, undertaking post-fire monitoring. Monitoring program has been established by Trust for Nature across all of our covenanted fire-affected properties to track how the recovery process is going through a system of vegetation condition monitoring and surveillance of new threats. Down to the nitty-gritty. This is our highly trained and skilled contractors use thermal scopes mounted on their rifles, particularly for evening and night work, sometimes during the daylight as well, and support their shots with the most stable and portable field shooting platform. We call them 4-legged shooting sticks. These 3 deer are at 150 metres and videoed through the thermal scope. They were killed instantly. It was only 2 weeks ago. The hunt was standing using this mentioned system, and all deer were killed within 32 seconds of the first shot. So the photo on the left is of a mature hind, approximately 3 years of age. The centre shot is at last year's calf, and the last little shot is this year's calf. Great to get 3 deer all very quickly from this bit of private property in basically 32 seconds. I think the results are a little greater than 180 now, but yeah, I think 184 to be, just had some calls this morning. Post removal deer population assessments have been shown an absence of deer from all properties, which is pretty much how we've found it right through this whole project. We start the project, there's often quite a few animals there through the population assessment, and then after a couple of visits, the animals basically gone. So fantastic product and project. And as you can see, that redneck wallaby is looking pretty happy in his new environment of fire, regenerating everything. So he's got lots to eat. And finally, here again is Max James up in the Wongarabel Valley, who's been very happy with the whole program, and a quote from him. "I'm very appreciative of the deer control. The deer seem to have gone, which is giving the plants a chance for recovery and growth." And really, guys, that's about it from me. I'm quite happy to answer some questions down the track. Thanks, Shay.
Thanks so much, Brett. That really sounds like a fantastic project, and by the sounds of that, quite a high amount of great outcomes coming out of that, which is fantastic to see. Thank you. I'd now like to welcome our next presenter, Neil Devaney from the Victorian Rabbit Action Network. Neil has extensive experience with on-ground rabbit control. Neil, over to you.
Thank you, Shay. Like everyone else, just let's cross our fingers here and we'll get into it. Okay. Right, so is that screen right, Shay?
Perfect.
Right, thank you. Okay, folks, so this is all about the rabbit problem. But the problem with the rabbit problem is that most of us don't see a rabbit until it hits us in the face by jumping across our paths. They're just sitting there in the environment and we often don't see them. And in the meantime, they're doing what rabbits do, and by and large, that's like eating the vegetation. Effectively, that's what rabbits do to harm everything, and that'll come up as a part of the presentation as we go on. So rabbits are engineers of the environment, and by that, this photo is a very good representation of that. In the front, you'll see a rabbit burrow, and then on the next ridge over, slightly to the left, you'll see another rabbit burrow. So that's physical engineering, where they actually interfere with the ground, dig holes, and so on. There's more evidence of the engineering in this particular valley, which I'll come back to where it is in a minute. But you'll notice the trees. If you look closely at those trees, there are very few of them for a start. But secondly, there are basically none that are endemic native trees. The reason for that? Well, that's the rabbit's engineering again. And you might ask, how come? And then further over on the other face of the valley, all that lumpy looking vegetation, that in fact is serrated tussock, which is another weed, which both of those are evidence of engineering of a different kind, which is a function of what rabbits do best, and that's eat. Well, second best anyway. That's eat the vegetation. So that same valley is in a place called Ingliston down in Victoria, nearish to Geelong, north of Geelong. And this is a photo of it in 2009 in December. By 2020, which just last year, that has changed to this. A vast difference. The reason being that back in that time, there were about 160 rabbits per spotlight kilometre in that area. There had been lots of efforts made to control the rabbits simply by poisoning, but not by using effective rabbit control. Whereas in July 2020, there are only 2 burrows found when the investigation was done. And this, in fact, is work done by Tim Bloomfield, who you'll meet a bit later. Now, these 2 little bunnies here do what bunnies do best, and the second best thing is eating vegetation. But what they do best is about propagation of their own species. So long as the grass is 14% better or better in terms of protein content, then after they do what they do best, very best, you'll have a litter of about 4 to 6 rabbits appearing in the environment. So already we're starting to see some evidence that 2 rabbits isn't really just 2 rabbits. Then as soon as the doe comes out of the burrow after giving birth to those rabbits, she is able to mate with the buck again. And then 4 weeks later, again, here we go, another 4 to 6 rabbits appear. And then same thing again, 4 weeks later, the doe comes out of the burrow and again mates, and then another 4 to 6 rabbits appear about 4 weeks later. It all sounds pretty terrible. That's a lot of rabbits, but in fact, by the time we get to this stage, the rabbits that were first born, the new kittens back at the start, they're starting to reach sexual maturity at 12 to 14 weeks. So of course, we don't just have the 2 rabbits now breeding, we now have more rabbits breeding. And so we end up getting more and more rabbits. And then all of a sudden, wham, bam, thank you, man, we've got a huge problem of all of these vegetation eaters and propagators of their own species. All because we started with 2 rabbits. We didn't see them hiding away there in the vegetation. And let's be fair, they're very hard to see when they're in low numbers, but we start to see them obviously when they're in larger numbers. Now, just to back this up, that little screen was something I put together as part of this project, but it reflects this Canberra experiment. A population of rabbits was fenced in, and this is back in about the 80s, I believe. It was exposed to predators as per normal. It was exposed to weather conditions as per normal. It was exposed to myxomatosis because at that stage, myxomatosis was out in the environment and could impact rabbits. 2 rabbits in that whole paddock, which was fenced in and rabbit-proof from the inside and outside. 2 rabbits survived, obviously 1 male, 1 female. After 18 months, the total impact on the environment of those 2 rabbits was that there are now 184 rabbits. So there's scientific evidence to support the previous slide. Rabbits do what rabbits do. One is eat, the other one is breed. So what makes them successful? Well, if you look at this particular picture, you'll see lots of success. If you look at the rabbits, you'll see there's a whole range of ages. So therefore, they're successfully breeding. What we do as people in our own environment is we provide nice green pasture for our stock. And if we're in urban environments, we provide nice green lawns, which are well fertilized, and they're cut, so they're nice and short, which attracts rabbits. And they're more than likely going to be 14% higher in protein. And therefore, that's enough to stimulate the breeding process. But what rabbits really need is the burrow. That's what makes them successful. The burrow is their stronghold. Without a burrow, the opportunity, the success rate of breeding is much, much reduced. So therefore, whilst it's the stronghold of the rabbit, it can also be their Achilles heel. So these particular species are all being influenced by rabbits. And in fact, each of them, these 2 in particular, is because of vegetation change, because rabbits eat the vegetation at a great rate. And so they expose these animals to predation, extra predation they wouldn't otherwise have. In the case of bilbies, they compete from burrows as well. But with the orange-bellied parrot, the rabbits eat all of the preferred vegetation and leave behind weeds like Galenia, which isn't particularly suitable for orange-bellied parrots. And then, of course, you've got things like orchids, which the rabbit will eat the orchid, but not only eat the orchid, they'll then dig up the rhizome or tuber, and therefore you've got no more orchids. So if the rabbits continue to exist in our environment, these particular species, and about 350 others, by the way, are likely to be disappearing from our environment. But if you look at it from the commercial proposition point of view, and just one example, it's roughly about 9 rabbits is equivalent to grazing 1 merino wether. In terms of the landholder here, that means around about $150 of lost production for every 9 rabbits that you've got, which is a pretty expensive thing for allowing 9 rabbits to exist on your property. The damage they do, good example of, they can ringbark trees. This is a plantation that was put in, and this, even though it's not demonstrated really obviously, but to the trained eye, you can see like with the deer that Brett was just talking about, there's a grazing height there. The rabbits have eaten up the foliage, and so there's no foliage close to the ground, which is really well shown in this particular instance, where a tree or shrub like that is particularly important that it comes right to the ground, so that anything and everything that's in the environment that is native and meant to be there can be concealed and have access to feed, which obviously is not available, or you can see in that particular slide, are weeds. So the rabbits graze as high as they can reach, and sometimes even climb trees to graze even higher. So what do we do about that? Well, as humans, we spend about $5 a plant that we put in trying to guard it. But the trouble with guarding it, rabbits can reach. So at the top of the guard, they start to trim the top of the plant, which obviously restricts its growth. So you've got yourself a plant with a crew cut. And if the rabbits don't tear it apart completely and eat it down to the ground, it might be lucky enough to survive to this stage. And I do say lucky enough. So, Shay, just a little bit of advice. I've got a menu bar at the top of my screen, which is in my way. How can I get that? I've shifted it. It's fine. I can do that. Okay. So we're about solving the problem. How do we solve this problem? One of the ways to solve the problem is to put in rabbit-proof exclusion fencing. And you can see the difference that's made in this picture. The previous slide was the part on the right where you can see the rabbit grazing height. The guards people have tried to put in to save the dollars that they've spent on planting the trees for the environmental sake. But on the left, you can see where it's been fenced in. There's been a lot of vegetation recruited, and given time, plants and other things plants that should be there are likely to grow. So best practice rabbit control is absolutely critical in terms of enabling native fauna and flora to thrive. It's based on science, in other words, research, and I gave you an example of that research before. It needs to be planned. It needs to be strategic, which means that it's got to be done at the right time. It needs to be coordinated. In other words, that means it's going to be lots of different people doing particular actions at particular times. So it's got to be coordinated. And it's got to be landscape wide, because rabbits don't respect boundaries. Like deer can go anywhere, rabbits can go anywhere, including climbing fences. So just a point of note, that rabbit-proof fence before might have stopped 90% of rabbits, but some rabbits will be adept enough to jump over the top or find another way over or under that fence. So that's why it's got to be landscape wide. Most importantly, it's got to be ongoing. So it's not just a 1 year shot in the dark and we're all done. It's got to be years and years of ongoing effort, being less effort as time goes by. So the ongoing stuff is in terms of maintaining the achievements that you've actually achieved. The most significant part about that, the most effective rabbit control, is where it's community-led and community-based. So controlling the rabbit populations. Here are the actions and timelines that we do. And you can see it's a cycle which reinforces my reference before to an annual process. The cycle involving count how many rabbits you've got, reduce their numbers, destroy their burrows, monitor the treated areas, come back to count what you've got left, and so that goes on. And we'll look more into those aspects in a minute. But all of those things happen at particular times. Add into that removing harbour. Harbour being the stuff that will hide a rabbit long enough to dig a burrow or provide protection from predators. There's the times that roughly fit the particular functions of each of those actions that might be taken. That'll vary from place to place, but generally that's in the Mediterranean climate we have the timing. So developing a control plan is obviously got to be planned, and it's obviously got to involve whole community. Plan and work with your neighbours. Don't think you're going to solve your own problem, but by the same token, if you can't get the neighbours on board, it's better to do something than nothing. So think and act landscape wide. And as I said before, rabbits do not respect boundaries. How big's the problem? Well, you don't know whether you've got a problem until you know how big it is. And it's a collective problem. So again, when you're measuring how big the problem is, make sure it's done with your neighbours and with the community. So spotlighting is a good way to count the rabbits, and that's obviously spotlighting, not carrying a firearm or shooting. It's just simply carrying the rabbits. So count the rabbits, note where they are feeding, and note where they run. And the reasons for that will become obvious in a minute or two. This is an example of a count. In fact, this is the one at Euroa. This is 2014, and it's a part of the 17, or what was 17, RHDV monitoring sites across the state of Victoria. Each number at the top, being 1, 2, 3, 4, is a 500-metre travel along a transect. So in other words, a route. And the numbers below each of those numbers is the number of rabbits counted in each section on 2 consecutive nights. So the first night there were 4 in section 1, then 6 in section 2, and so on. And the second night there were 7 in section 1, 3 in section 2. Remember, this is exactly the same route. So on night 2, there were 3 rabbits that we didn't see on the night before. Well, there might have in fact been 7 rabbits we didn't see the night before, and we didn't see any of the 4. So lots of complexities there. So the numbers themselves are critical data to knowing how big your problem is. But then if you graph it and analyse it, these are rabbit numbers up the left-hand side. These are the distances in 500 metres. So every one of those columns represents the number of rabbits for each 500 metres of travel. And again, this is a site at Euroa on a transect that's been running for now 25 years. This is in 1996, just before RHDV was first released. And so you had peak numbers in various sections, around about 140. It shows where the hotspots were, and that's obviously where the columns are tall. It shows where there wasn't so much of an issue, and where there are very few rabbits. The reasons for that is because the landholders who have those properties are in fact had done a lot of work on rabbits beforehand. Now, realise that this is 16 kilometres, this count, and it's over about 7 different landholders. So you can analyse the data by calculating the number per kilometre, and I quoted a figure like that before. You can calculate the number per hectare, which is important in terms of impact on stocking rates and revegetation and natural recruitment, because anything more than 1 rabbit per hectare is not going to allow regeneration to occur naturally. And you can find out where the greatest densities were. All of those things help to inform the planning. So how big's the problem? Part of that is by mapping burrows, and this is Rabbit City. I talked about boundaries before. This burrow goes on from one property onto the other property. And I was on this site just the other day, and we're getting the two property owners to work together there. So locate and map all of the burrows. Absolutely critical. This is an example of a golf course. All of the white spots show where the rabbits were located. The burrows at least were located. And there were 60 in this count, and when work was done, there were more and more being found as the work progressed. This is an example of a rail trail, and as you can see, the analysis has been done in terms of warrens per hectare and so on. All of this informs you about how big your problem is right here and now. When to act, that's the strategic part. So pull out your calendar, use this particular information, which actually, as you can see, comes from the AgVic department. I'm sure Nigel will like to see that. And you'll see the actions that can be taken across the top, and down the bottom, you can see the ecology, and Brett referred to the ecology of the deer. Matching your actions to the ecology of the rabbit is extremely important as well for it to be most effective. So again, I stress, be sure to act at the same time as a group and across the landscape, not just in your little patch. So the next part is make it integrated. We've got a range of integrated tools. So we've got a range of tools that complement each other in that effort. To eliminate rabbit harbour is a part of it. And so you eliminate woody weeds like blackberry, or eliminate rubbish like this that often is on properties. It could be a container on a block, it can be a wood heap or anything like that. So somehow or another, you need to remove that harbour which provides the opportunity for rabbits to be protected from predators and the opportunity to dig burrows because they got time without being threatened. Reducing the rabbit numbers, that's knocking the rabbit numbers down. The traditional or the most effective methods, in fact, are through baiting, and the baiting can use the registered products being 1080 or Pindone by a suitably qualified person and somebody who knows how it's applied to minimise risks and so on. But it is by far the most effective way of knocking down rabbit burrows. Rabbit numbers. If you don't do that, there are implications which will become evident in a little while. Next part, we have biocontrol at work, and it's been at work ever since the days in the 50s when myxomatosis was released. It would never be released these days because it didn't have all the hoops and to jump through that nowadays we do to do with animal ethics and so on and approvals. But myxomatosis is still out in the wild, in the environment, doing its job. Then there was RHDV1, which was released back in the 90s, and that took many years, 10 years, to be approved for all of the reasons that I fully support of animal ethics and so on. But if you see a rabbit that looks like that, it will have died as a painless enough death. It dies from organ failure, but it will be sitting there peacefully looking like it's resting with its head back, its paws out. It may have a little bit of blood at the nose. Then in 2016-17-ish, again, RHDV K5, the Korean version of the rabbit hemorrhagic disease virus, was released, and it then also had a big impact, a significant impact on rabbit numbers. At the same time, a rogue virus came to Australia, RHDV2, and it really took over. It swamped everything else. But the important thing here is all of those things are currently in the environment. They are all affecting rabbit populations and keeping numbers lower than they might otherwise be. How does it spread? Well, in this case, with RHDV and virus, it's spread by a fly. Any fly that lands on an affected rabbit and picks up the virus from the rabbit has then the potential to pass it to another rabbit. The rabbit stronghold. Well, how deep's the burrow? We know it's the burrow. How deep's the burrow? Firstly, profile the burrow. In this country, in the Kiowa Valley, where there's heavy red soils, those burrows are around about 70 centimetres deep. With this one, down on the basalt plains near Melton, Bacchus Marsh, those sorts of areas, they were down to 900 millimetres to a metre. So it depends, the depth of the burrow depends upon the soil type and the water table. In this case, where Brad's sitting at the bottom of that, it was stopped by rock. In many other places, it's stopped by the water table. We don't want our little bunnies being born into water and therefore not surviving, or that's if you're a rabbit parent. However, the rabbit's burrow is also the rabbit's Achilles heel. So it's the Achilles heel in the sense that we can modify that burrow, in other words, destroy it, using heavy equipment like a D6 dozer or bigger. It's got triple tine rippers, and at the front it's got the blade, which can be used to backfill any ripping that's done. Another alternative, the advantage of the dozer, it's very quick across the ground, so I can move around quickly. Another alternative is a 20-ton excavator. And notice we're talking about big machinery. Little machinery doesn't cut the caper in this one because it doesn't have the power to get through the burrows. Notice the triple tine ripper on the boom of the excavator, which can be replaced by the single tine ripper that's underneath if that's more appropriate for the particular site that's being ripped at the time. If either of those, this is the quality insurance part of that ripping process, with the dozer or the excavator, one of the important things is to track roll the area, one, so that the rabbits have got less chance of getting back in, but secondly, if you're driving across it, you don't want all the lumps and bumps to cause a lot of discomfort and moving around your paddock. And the other thing is that this person here is the spotter, and the spotter's role is critical in making sure that each burrow is ripped to completion and then taking the operator of the machinery to the nearest next burrow so that reduces cost and time is minimised. So if all of those things don't work and you've got places where you can't get to with your ripper for whatever, be it infrastructure or steepness or whatever, then we have this option. It's a minimal disturbance option, and it's where you use implosion, which is not an explosion, but sufficient enough explosion to cause the burrow to implode on itself. In other words, it destroys the structure of the burrow. For quality control and follow-up, you should always monitor and follow up. Now, in this slide here, the problem was that the rabbit numbers hadn't been knocked down beforehand. So there are plenty of rabbits on the outside ready to dig back in. And you can see the activity of that burrow where rabbits have tried to, and effectively, dug back in and reopened a burrow, which this particular one had been fumigated for reasons of it being near a culvert in this particular case. And if it does open, then you fumigate the burrow by the approved methods. So it needs to be landscape wide, and in our area, over the last years since 2008, this gives you an indication of how many hectares, that's roughly 90,000 hectares, that we've covered with various programs of rabbit control. It needs to be ongoing, and hence it's still going, still current, but the level of work is a lot less. So if you want to know how successful you've been, it's not about the number of rabbits you killed, it's about the number of rabbits that remain. So you repeat your count. This is the count in 1998 after some work had been done. Pretty obvious where the work had been done and had been supported by the minimal numbers of rabbits due to the knockdown from RHDV K1 in this particular case, because this is 1998. But you can tell where the landholder had done absolutely nothing, the rabbit numbers had started to rebound back significantly. So the gold standard rabbit control method is what I've just been outlining. And if you deviate from that in any way, then you compromise the outcome. You'll still get an outcome, you'll still get an impact on your rabbits, but it's just going to take longer, much more effort, and be more costly if you don't. So the key ingredients of these: destroy the rabbit burrows. Without the burrow, the rabbit's chance of successfully breeding are very, very small. Have a plan, and we're talking about the community and you on your land holding, and stick to it. Be persistent. Act as a community with a common goal. Understand and accept that it's a long-term project. And as you heard me mention before, it's been going for 25 years in our area. And for those landholders who've kept up the effort now is minimal. To be determined to succeed, and do not give up. So the long-term effects can be achieved. This particular graph shows the number of rabbits for each of those, the number of rabbits for each count. So in 1996, there were 1,070 rabbits in those 16 kilometres. Over the period of time, the next 4 or 5 years after the release of the RHDV, a lot of work was done, rabbit numbers started to come down. Then from about 2007 onwards, the counts were in total, this is total counts, about 60. That was maintained for some time until recently when K5 and RHDV2 had their impact. The counts are now down as low as 10. And in fact, 2 weeks ago, the count was done for our area. And on the first night, it was 10 rabbits. On the second night, it was 11 rabbits over the whole 16 kilometres. Success can be achieved. Now, as was said earlier, I'm a mentor with the Victorian Rabbit Action Network. I encourage you to go to our website. There's the site there. There are lots of resources that are available, access to other mentors who are across the state and are available for advice and support in your development of your community-led rabbit action program. Thanks, Shay.
Thanks, Neil. That was a fantastic presentation. And I have to say, wow, those two comparison photos at the start, absolutely mind-blowing. And it's great to see that when a landscape community-led approach takes place, our natural environment can recover.
Exactly.
Thanks, Neil. I'll now go over to our next presenter, John Reid from Ecological Horizons. John is involved in feral cat management with particular interest around new advances in technology. John, over to you.
Thank you, Shay. Hopefully we can get this going. So just yeah, welcome everyone. I'm a bit of an imposter. I'm from South Australia. I'm calling from Bungala territory on the Eyre Peninsula, where I do a lot of ecological work on feral cats, but also rabbits. And I'd just like to reiterate a lot of what was said in that the last talk. And we have a saying over here that it's the rabbit that makes the warren, but it's really the warren that makes the rabbit, which I think is pretty important. And just another segue from the rabbit talk, the most effective feral cat control that I've ever seen was when RCD first went through, the rabbit hemorrhagic disease went through the desert here in 1996. And rabbit numbers crashed and cat and fox numbers crashed as well. So yeah, just a bit of a segue there. Now I just need to get the slideshow happening. Help please.
From beginning, mate, up there on the left.
It's slideshow.
Yeah, so just over to the far left under file from beginning.
Yep.
Just below that, nope.
No, I haven't. I've got the that little bars in the way. My little okay, now we go from beginning.
Yeah, perfect.
Okay, thanks everyone. So yeah, I've been asked to talk about the use of felixes for management of cats, particularly in bushfire type areas. And yeah, over here on Eyre Peninsula and on Kangaroo Island, we suffered really badly from the same fire season in 2019-20 that also affected Victoria and New South Wales. So very familiar with that. I just want to start off with some general discussion about managing cats and the challenges of managing cats. And one of the first things is that anyone that's ever owned a cat knows that many cats are fussy eaters, and they're difficult to control using conventional tools such as food baits or lures, unless they're really hungry. So cats will often walk past a bait, no matter how good it looks to us, if there's a mouse or a quail or a lizard running around. And it's only when they're getting really hungry and they can't find alternate prey, they generally take baits. This actually leads to a bit of a challenge. Sometimes if you can conduct really effective cat control using baits or baited traps, initially you can knock down the cat numbers, but then what happens is that their prey increase in abundance and availability, and then the cats become harder to control again. So you might get initial knockdown, but then it's not sustainable because their prey has increased and it makes them harder to trap or bait. Cats are also attracted to burnt ground. There's been a number of studies done around Australia with radio-collared feral cats and showing that they can move to fire grounds, often tens of kilometres. And the reason they do that is that their prey are generally a lot easier to hunt in open ground than they are in thick vegetation. So so cats can be attracted to fire grounds, and it makes fire grounds a really important place to conduct control. Of course, allied to that is that if you have extensive fires, especially in the habitat of threatened species, those threatened wildlife are most vulnerable post-fire when they have less cover to hide in. So the importance of cat control is often greatest when conditions are really open. And once again, that's allied to the rabbit talk. If rabbits or deer or anything have cleared the country and cleared the understory, it makes predators and predation more efficient. So in burnt grounds or in overgrazed grounds, that's when your threatened species are more likely to be predated by cats. And another issue too that we strike often when trying to deal with feral cats or foxes is that most control tools also threaten pets and working dogs. So often baiting might be really efficient for foxes and sometimes effective for cats, but we can't generally bait in areas where there are working dogs or pets having access. So these are all some of the challenges we have for feral cat control. I've been working in this field for about 15 years and or actively researching tools. I've actually been an ecologist managing feral animals and threatened species for, closer to 30 years, I'm afraid to say. But got a group of organisations together to collectively fund the development of the felixes, which I want to talk about today. And we've actually established a company, well, two companies, a non-for-profit charity called the Thylation Foundation, and also Thylation R&D, a commercial company to commercialise felixes and other tools to improve conservation success. I'll just very briefly describe how they work. So they're automated. They're a box about the size of an esky. This picture you can see here is a woylie or a brush-tailed bettong, like a, slightly larger than a rabbit. And the felixer has 4 sensors that are measuring the distance to where they intercept an object. And you can see this woylie is passing underneath the 2 activation sensors. If that was a cat, those 2 beams would be striking the rump and the shoulder, doesn't matter which way it's going. And you'd recognize an animal about the height and length of a cat. These sensors also pulse at 1,000 times a second. So if it was a cat passing across there, we'd know how fast it was moving because of the time taken between breaking the first activation sensor and the second one. And some of the Australian animals that are similar size to a cat, like a wallaby or a paddymmelon, when they're hopping on 2 legs, they actually move faster than a cat. But when they're using their quadrupedal motion and their tail, they actually go slower than a cat. So we can distinguish animals by their size and also by their speed. There are 2 blocking sensors on a felixer as well. The first one is at about knee height, and that's higher than any cat that I've ever seen. And I've dissected over 1,000 feral cats, so I've seen some pretty big ones. This blocking sensor is there to protect larger animals, kangaroos, dingoes, Toyotas, people, sheep. And if that top sensor is broken, the felixer shuts down and won't fire. And the bottom blocking sensor also needs to see between the legs of cats and foxes. If it doesn't, then if there's no clear space underneath the belly of the cat or fox, then it might actually be a wombat or a possum or a low-slung Australian native wildlife. So they use that array of sensors. And I have a video here to show you of one in action. So this is a pen, a trial pen set up, and this is a feral cat, and the feral cat is about to walk past a felixer, and hopefully you can see what happens when he walks past. It's really important that you notice that the felixer operates very quickly and suddenly, and the cat's, it takes the cat by surprise, but the cat's not hurt by it. I might even be able to play it again. I actually like watching this several times. I hope you do too. I just want you to notice that the cat is not hurt at all, and it gets a red splotch on its flank. The gel has been specially made to be sticky and tasty, and so the cat will lick it off and ingest the poison. So there we go. I'll resist the urge to keep playing that video. Some more information about the felixer. Each cartridge is a sealed dose. So unlike a bait that gradually breaks down and potentially exposes cats or foxes to sublethal doses, the entire dose is sealed in a cartridge. And the dose that we've got is highly toxic to cats. So you really only need 1/5 of a dose to kill a cat or 1/10 of a dose to kill a fox. But yeah, you need multiple doses to affect children and native wildlife. So it's highly specific. The reason we have a higher dose than is absolutely required to kill a cat is that we're not 100% sure that all of the spray will hit a cat, and we're not sure that a cat will groom all of the spray. So there needs to be a bit of leeway there. And also our friends from RSPCA and other welfare organisations are pretty keen on having the quickest death possible. So the higher the dose, the quicker the death. So what we've adopted is a dose rate that is intermediate between being safe for humans and native wildlife and ensuring as rapid as possible death for the cat or fox. This is just a slide showing where we had felixes deployed in 2019. It's increased significantly since then, but I just haven't updated my graph. There are now felixes operating with toxins, killing cats in every state except for the lovely state of Victoria, I'm afraid, where there's still some issues around the designation of cats as a feral species that can be controlled using 1080. So we're actually looking at trialing some different toxins, a toxin called PAP, which may be able to be used in Victoria in the near future. Just to explain that every time an animal walks past a felix, a photograph is taken, and some metadata, some information around when the photograph was taken is also recorded. Here are some images here showing some cats. It's showing that the trigger that these cats were recognized as a target and were fired. The top one was fired at a distance of 184 centimeters away from the felixer. You can see the date that it was fired and the serial number of the felixer. There's a whole lot of other information too about what lure was playing at the time, what the temperature was, and who the owner was. And we can sort on all this, and we've now got information from several thousand cats and over 100,000 wildlife going past. And we use this information to upgrade the algorithms that distinguish the different animals walking in front of them. Getting back to the actual deployment of felixes for post-fire management, the top photograph there is actually a fence on my nature reserve. My wife and I own the largest private nature reserve in South Australia called Secret Rocks. And we had a fire go through and burn 10,000 hectares of that, including a significant part of one of our exclosures in December 2019. And immediately, because we had malleefowl and a threatened dunnart species called the sandhill dunnart inside there, we reinforced this fence, which was somewhat burnt and shrubby. We reinforced that with felixes. And we also put felixes on fire tracks that went through. So as I mentioned before, cats go to the edges of the fires and like hunting along there. They also use cleared tracks through the bush. So these fire tracks became key conduits for cats to recolonize the area, and we targeted them with felixes. And the same happened on Kangaroo Island, where there were some extensive fires. Again, there was another different species of threatened dunnart, and I've got some information here on the efficacy. This is the Kangaroo Island trial, where Kangaroo Island Land for Wildlife, a similar sort of organisation to what you guys belong to, were doing some targeted feral cat control in areas that were burnt, and they started off using cage traps, which is all they had, and the efficacy of cage trapping declined. So what they did was they caught the easy cats and weren't able to catch the more challenging cats. And then in January 2021, they brought in some felixes, and you can see, despite continuing with the trapping, the felixes started taking over as the most efficient technique there for taking out those cats that they couldn't get with the other techniques. And just some data from that, we actually had two different groups of felixes there. That's not really important here, but just to show that with the felixes deployed, with 10 felixes deployed in this fire ground, they were averaging, between sort of 5 and 15 cats that were actively targeted a month. And although there was a spike in May, it's important to note that the felix efficacy didn't really decline. This is also represented by several other studies we've had that have been going for a year or two, that it's not just an immediate knockdown and then you're not getting many cats. There's always cats reinvading, and felixes are picking them off as they're reinvading. So in that trial in the fire ground on Kangaroo Island, 53 cats were effectively targeted in 6 months. One of the cats we were particularly keen to get was this one that we called the bullseye cat, due to the markings on its flank. It was photographed by one of their trail cameras on June the 28th. And only sort of a couple of weeks afterwards, we got the same cat targeted by a felixer. So the bottom photograph was actually taken by a felixer, and as it was being targeted, and despite having a network of trail cameras and felixes around, that cat wasn't subsequently detected. And The same goes for, in an earlier trial on Kangaroo Island, they had 8 radio-collared cats. Each radio-collared cat that was targeted by a felix was found dead within 24 hours, and it was proven to be through 1080 poisoning. So we're pretty confident that most, if not all, of the cats that are targeted do die, although it's hard to find their carcasses because they tend to walk off. They'll groom, but the 1080 doesn't actually start. It starts metabolizing. It becomes toxic after a couple of hours, and it might be 6 to 8 hours before they start showing symptoms at all, and then they might die, you know, within sort of 10 to 24 hours. So they're normally a fair distance from the felixer. The felixer has 20 cartridges in it. It automatically reloads and it's ready to go with the next one. Just a bit of information on some non-target species here. So in this trial, you know, we had thousands of Tamar wallabies go past, and you know, only a very small percent, less than 0.05%, were considered to be targets. And the same applied to Western grey kangaroos and brush-tailed possums. There was, however, a challenge with koalas, and it doesn't really show up on this graph because of the scale, but pretty much a third of the koalas that walked past were misidentified as targets. And so we only had the felixes in areas where there were koalas walking around post-fire in photo-only mode. We didn't have them in toxic mode, and we're working on some developments now to dramatically improve felixes so they can be deployed where there are koalas. When we designed felixes, we weren't thinking about post-fire habitats with koalas walking on the ground, and so that's just one of the challenges we face. I've nearly finished. I wanted to rip through in case there were some questions, but just another tool we can add to the felixes is that we have the ability to block them firing if pets or working dogs are equipped with a Bluetooth tag. So you can see this lovely fluffy cat. This was a prototype tag. The actual tags we've got now are about a quarter that size, that weigh less than 10 grams. And the battery life lasts for 12 months. So we've got some peri-urban councils that are interested. They've got cat-free zones, and they want their cats registered and with these tags. And then they feel they'll be able to deploy felixes in peri-urban parks and nature reserves if they've got a good take-up of these tags. So it just provides another tool, also provides a tool for farmers. Their working dogs should be fine, but if they've got any pups that are smaller and could activate a felixer, if the pup's wearing a tag, it won't. And so they can have peace of mind that they can conduct their cat and fox control without affecting their pets. And here's just a photograph taken by the felixer. As I said, the felixer takes photographs of every activation. You can see on the top photo, it's that same white cat. You can actually see the 2 white beams. That's the infrared beams that are only visible with the felix's infrared camera. You can't actually see those beams when the cat walks past, but they're the 2 activation beams. And when this cat was photographed, it was recognized as a target, but you can see it was blocked. It says photo blocked. It was at 137 centimeters from the felixer when it was blocked. You can see the date there and the felixer number. And it was just a matter of, a couple of months later, this is a feral cat that walked past in the daytime, so you can't actually see those white activation dots, but it was recognized as a target. So the same felixer would enable the pet cat to walk past, but target the feral cat. And here's just some data from that trial there. On the left there, the far left, you can see that on about 22 out of 65 occasions, the untagged cat was recognized as a target. The cat wearing the tag was recognized as a target, but was blocked on all occasions. And most of the non-target animals were not targeted at all, but you can see here again that Cape Barren geese actually also provide a bit of a challenge for us. So we're working on algorithms that enable us to distinguish geese from cats. And interestingly, we've got 10 felixes across on Christmas Island at the moment, and the only animal of similar size to a cat over there that is tripping us up is the feral chicken, and they've got chickens everywhere. And so we've developed an algorithm that can be used on Christmas Island that can distinguish chickens from cats. And just one more final point, when we're managing cats, often there are foxes in the same environment, and often it's good to manage them both together. We've had examples where effective fox control has led to increased cat numbers, and it's possible that vice versa also happens. So if we can control both pests with the same tool, it's advantageous. There's an island called Bird Island, very uniquely named, just off Port Adelaide, where fairy terns nest, and they had issues with foxes occasionally walking across the island on low tide. They deployed a felix out there. They found that the felix detected the fox as a target and fired on it. And a few days later, they went out there were no more fox tracks, and they found a dead fox. That's happened now twice, and they've had one of their best fairy tern nesting seasons out there. So although we don't have a lot of data yet on foxes, we're aiming to do that and have some radio-collared foxes and follow them and prove that felixes are effective for them as well. But some data from some of these initial trials and some pen trials suggest that felixes are also effective for foxes. And just to summarize, I see Shay's come back on, so maybe I'm running out of time, but felixes offer solutions for post-fire sustainable feral cat control because they don't rely on cats being fussy eaters. They don't rely on cats taking baits when they're not necessarily keen on taking baits. They can be placed in areas where cats are attracted to fire grounds and things like that. And they can target areas where threatened wildlife and where working dogs are found. So that's the end of my talk. Thank you.
Thanks, John. That was really interesting. I have to say, it sounds like a lot of work has gone into the construction of the felixes, and hats off to you guys that were all involved, that's for sure.
Thank you.
John's last slide around foxes leads us nicely into our last presentation, and that is from Tim Bloomfield. So Tim has had over 40 years experience in on-ground pest and land management, and he will obviously be talking to us today about fox management. Tim, over to you, mate.
Good on you, Shay. Thanks very much. And I'll start the share screen bit. And thanks very much for the other presenters. Very interesting and useful information. We'll have a go at this. How's that, Shay?
Perfect.
Perfect. Okay. So this little picture is a demonstration of the sorts of landscapes that foxes like, and it's a landscape that has been cleared. Another factor that also advantages our friend the rabbit as well, and other invasive species. So this is excellent for foxes on the basis that they like to hunt edges. There are edge hunting species, and what you find is that this sort of cleared area here is ideal for them. The forest area that's in the background, they'll tend to be along tracks, along fire trails, and in cleared areas. There are species that's hunting small animals, and they're hunting small animals generally on the edge of waterways, on the edge of patches of timber, etc. Foxes are excellent hunters. They're extremely good hunters, and they even impact on species that they've co-evolved with in Europe and Northern Africa. European red fox has fantastic eyesight, excellent hearing, good sense of smell. It can affect a broad range of species, and we'll get into that. Breeding around about June, July, you'll hear fox calls quite eerily in about that May, June period, and we've got getting cubs born basically through very late August, September, October, and then dispersal of foxes. That's the young. So all the males and females that are born get pushed out of their territory. So this is a constant thing that's occurring, and this is a factor in the spread of foxes across the landscape. Now, when foxes were introduced about 1869 or thereabouts, they spread across the whole of Australia in a period of basically less than 100 years. That type of dispersal is a social behaviour of foxes. It's occurring at all times. So if all your foxes on your property died tonight, tomorrow another fox would be investigating the territory previously held by the previous fox. a territory that is marked by urine and scent, territories that are also held by vocalizations as well, indicating that I'm still here, etc. So we've got this ongoing process that's occurring all the time with foxes. Now, thanks for Neil and an excellent presentation on rabbits. And rabbits are an important factor in the diet of foxes, about 40 to 60% of their diet. They also create holes that foxes might use as dens. They also spread seeds of woody weeds and create harbour for foxes as well. The more rabbits, basically, the more foxes. And I was interested by what John said in regard to RHTV. At an 1,100 hectare site near Werribee, where we've done a lot of rabbit control and taken them from about 200 per spotlight kilometre to about 0.5 per spotlight kilometre. There was basically varied between about 8 to 10 foxes per spotlight kilometre. It's now running 0.3. They are a very important factor in the survival of foxes, but foxes also do other things. And the thing that they do really well is impact on native species, particularly ground nesting native species for birds, or with the rest of our native species of a particular weight range as well. So these Cape Barren geese here are significantly impacted in nests, and these young birds here are not able to swim away or fly away. And as Troughton indicated way back in 1938, the assurance for the future, that's the future of native species, is reserves from which you can exclude foxes. That has been proven to be the case quite significantly. Foxes have an impact on species around about 35 grams to 5.5 kilos. They're a middle order predator. So there are species that is expecting actually to be attacked by something bigger than them. It might have been a wolf at one point in time, or bears, or humans indeed. And so their behaviour is one of a species that's trying not to be detected. And so they're difficult to detect without, and we'll get onto those couple of monitoring methods fairly soon. But here are some species that rabbits do impact actually, but also foxes, and foxes impact them quite significantly. And there's evidence, and people much smarter than me work this out, that the European red fox is a better predator than many of our native species are at avoiding that predation. And that's basically because they've never had a predator like that before. And as occurs with many island species, the superior predators come in and wreaks havoc. So you clear areas, you make them more useful for foxes to hunt in. You break up that bush and that habitat that suits these species, and then you bring in a superior predator. It's going to have a massive impact. Here's the anti-predator behaviour of an eastern barred bandicoot, which is pretty much to run. When it detects somebody, stop, then run again. They're quickly and easily killed by foxes, killed by cats as well, as you can imagine. They simply do not have the anti-predator behaviour to avoid them. Rabbits do, and yet rabbits are also a significant impact in fox diet. They are an excellent predator. So what are we going to do about them? So here's just a graph that indicates some control measures that have been used on foxes. Some very common control measures: trapping, whether it's a soft catch trap or a foot snare, hunting, pushing foxes towards people with guns, using dogs, or hunting them down with dogs, or using dogs to get them out of dens, etc., or spotlight shooting, again, a very popular process, and baiting. What's exampled here is what's the most efficient and most effective. And baiting by a long way is the most efficient and the most effective. Remember, this is a highly adapted species that lives everywhere from arid areas to the Alps. It lives from the coast to temperate forests and urban areas. Foxes adapt to the behaviour foxes adapt to their environment. And if you put a lot of pressure on foxes by trying to kill them, by trapping, hunting, shooting, they'll adapt to that and they'll change their behaviour and become less available. You might kill a lot of foxes, but there will still be foxes left. And the important component there is that foxes are known for multiple killing behaviour. So that's where if they see, if they're close enough to species which fit into that range of being prey, they will take advantage of that by killing those that they can get to. And effectively, they might kill 5, 6, 7, 8, 10, 12 of those animals, whether they're bandicoots or penguins, in a few minutes. People have seen the same thing happen in their chicken coop. So one fox can have a significant impact. The common method in using baits is to lay baits, and it is for them to be buried in the ground. Now, each of these products are registered products. There's a label for them. You need to read that label and follow those instructions. You need to have an agricultural chemical user permit, that's in Victoria, to be able to access and use those baits. And there is a course that you can do for that. And I think you'll find that information probably on the AgVic website. The two toxins are 1080 in PAP and 1080 is sodium monofluoroacetate. They're in different bait mixes. Each of those in different degrees are attractive to foxes. They will smell those very baits out. There's also aerial baiting. It's unlikely to be done by individuals, usually by governments, or on very large areas. Berry baiting is the simplest, the easiest. There's also another product called pest injectors. You'll find that information. In fact, I'd go to the Animal Control Technologies website and you'll find information on that. Here you see bait take. The bait was actually placed amongst some dried grass here. There was a pile of earth. The fox is investigated. You can see the fox tracks there, human tracks. The fox has taken the bait. Sometimes foxes cache bait, which means that they rebury them. This is not a hobby. It's a behaviour that foxes have for the purposes of returning to it. And if that individual didn't return to it because for some other reason, maybe it died by taking another bait, then another fox that would move into that territory may well discover it and dig up that bait and consume it. So if you're going to have bait stations and you're going to try and determine what foxes were there and what foxes weren't there, you need to know what their tracks look like. So here we've got fox, here we've got dog, and there we've got cat. Foxes have very hairy feet. They come from the Northern Hemisphere. They expect to walk around in snow. You can draw a line from the top of the back toes through the nails, and it won't encompass the front toes of the fox. Whereas dogs, it tends to encompass the back toes are around the front. You always see nail marks with dogs on pretty much every surface. Foxes only in very soft sand or mud, and you can see a very significant difference with a cat track. You'll also find scats of foxes. Foxes will commonly put scats in bait stations. That indicates that it's a high quality food source. They use scats and urine to indicate the quality of food sources and where they are. It's just a marker. This has got shearwater in it, a lot of feathers. There's lots of beetles. There's rabbit fur, pieces of bone, some wool in this one, and seeds of Apelosodum. So fox is extremely good at spreading seeds. Blackberry is a common one, briars another. What rate of bait lay should you have? I won't go into the details of bait laying. You can find that at other sites, or we can answer questions separately. But pretty much you need to give every fox the opportunity to take a bait, and you do that by putting a sufficient density across the landscape to enable foxes to be able to come onto those baits. You don't need any special knowledge of the way which foxes walk through landscapes. You simply need to have bait across the landscape in a density that foxes are likely to find them. That density here, and I've just selected a few studies, is generally somewhere in the vicinity of 2.6 to 3.5 times the density of foxes that you might have in your landscape. Now in Victoria, that would be looking at density of around about 10 baits per square k, at about baits about 250 metres apart. There's a number of things that you have to do in regard to baiting, in regard to the use of baits, and that's covered in your agricultural chemical user permit, and that's also on the label of the product. But the key factor here, when you're dealing with foxes, is what you're trying to do is give every single fox the opportunity to die. You do that by bait density, you do that by using other control measures. It's only by the reduction, the significant reduction of foxes, that you can get a response in the native species. This is what happens with a fox baiting program. Now, this is from work in East Gippsland. They've got a long period of free feeding there. And you might have noticed in the previous slide, there's a free feeding. So that's a non-toxic bait that gets the foxes to come to your bait station and return and return and return. Foxes very quickly optimize food source that requires no energy and no effort and little threat to obtain. Here, this is a 6-month period. I've found 15 days to be quite good. I tend to get maximum uptake of foxes by that point in time. Then you put in your toxic bait. Then you'll have a massive decrease in foxes. And then as foxes reinvade those areas from adjoining territories, bait take will rise and fall based on pretty much the numbers of foxes that you might be getting coming in back into your area. Where are those foxes in that landscape? Well, what I like to do is I like to do a den survey. So I like to look to where the foxes are denning. So foxes use a den, which is an earth hole that they have their cubs in. It might be under a pile of sticks. It could be in a log. It could be under buildings. In urban areas, they're often under grave sites as well. They're very distinctive. You can see fox tracks. You'll see fox scats. You may even smell foxes. You put a camera up, a trail type camera to detect that the foxes are using it. This area here is each cross is a den site. The major den sites are actually around where the water areas and most of the rabbits live in that zone. They don't use all of the dens all the time. They'll select dens usually about sort of April through to June, and then they'll use the den that tends to be the one closest to available food sources for that year. Dens you can use as a way of assessing what foxes that you've got on the place. It's a sort of monitoring approach. If you imagine that your property is one of these, either in the A, B, C or D area, if you control foxes in your zone, you'll quickly get foxes invading, colonising from adjoining zones. So ideally, you're working together and you're working over the largest area that you can. In this situation, breeding dens were about 1.3 to 1.5 k's apart, which is just the spatial distance that indicates the amount of food that was available for foxes was sufficient within that zone between those dens. You can fumigate dens. There's a product called Denko-Fume that uses carbon monoxide for that. Pretty much you light a fuse at one end, placing it in the den, and it's the carbon monoxide is liberated and the fox goes to sleep. They do. Another method is you can use implosion to destroy dens. You can also use mechanical means to do that too. Dens are nonetheless an indicator across the landscape of the foxes that you've got on your property, and you might want to use that as a way of censoring the population. So what do? Well, ideally you'd have a fence, or you live on an island, so that all of the work that you've got can be maximised and you don't get immigrants. Barring that, you need to monitor what foxes you've got before you start doing any control work. Mainly because foxes will change their behaviour once you start doing things that they work out you're trying to kill them. So you start shooting at them using den dogs or hunting them. They'll change their behaviour. They might appear scarce, but they'll actually still be available in the landscape to kill either your lambs, your goats, kids, or your not kids, or native species. So the den search, GPS, all those, put up some trail cameras in areas to get an idea of the sorts of numbers that you might have. You can spotlight, you can count the number of foxes that you see per spotlight kilometre. Now, if you later on go shooting foxes with spotlights, it's going to affect that as a monitoring method quite significantly. You bait across that area to density reflects the number of foxes you've got. You try and involve all your neighbours, your national parks, your state parks, etc. When you have your fox numbers down at very low levels, then you can start to do the other approaches, which is to try and remove those species that may be bait shy or may be highly neophobic. And there is always animals in the population like that. Ideally, I would be removing my woody weeds, I'd be spraying my blackberries, I'd be getting rid of my gorse, I'd be getting rid of my boxthorn, and I would be doing bottom-up work, which is I would have removed my rabbit population, I've destroyed all my burrows to ensure that I'm not carrying more foxes than I might reasonably carry. Now, you mightn't do too much using of the hounds. A bit of a limited supply. It's also just going to scare a whole lot of things, and it's not really that successful. For, as they say, as much as I hate foxes, I love the hounds more. A bit more of a recreational thing. And people have also used dogs. Marimas are very popular as sort of sentinel dogs. They work best where you've got a group living species, a social animal, which they can guard more easily than those that are more independent or are not social living. Let's just say like eastern barred bandicoots, they don't live in groups. It's going to be more difficult for that guard dog to intercept foxes. Now remember, a fox is a middle order predator. It is in a long period of coevolution with things that want to kill it. It's pretty good at getting past or taking advantage of the environment when the dog isn't present across the whole of that landscape. It was able to have an influence across the whole of it. Bounties, I just got to mention bounties because for some reason Victorian government seem to be in love with it. Fascinatingly, the Labor government is in love with it. So the Liberals, I'm not sure who the votes they think they're stealing. My studies indicate that the number of people who enter those schemes to shoot foxes when bounties are announced is very low. It's the people who are already doing it who get the benefit of it. They usually think that they're getting the money back that they should be getting back from the government. The effect is of a low culling effect, and I would strongly suggest that more foxes are killed by road traffic. And fascinatingly, this cub that's been run over has then been scalped by somebody who's then collected a bounty, such as the nature of bounties indeed. So I dropped the bounty and put that money into something else useful, like community rabbit control, broad-scale fox control. Who benefits from broad-scale fox control? Well, I'm using Phillip Island as an example. Great Barren geese have increased tenfold. Redneck wallabies here probably increased 100 times. The Mars lapwing, you can find them every kilometre, you'll find 2.8 of them, whereas in Victoria, whereas across the water in Bash, you'll find 0.5 per kilometre. Possums change distribution and density quite significantly, and on that place, penguins have increased their distribution, and even the good old hooded plover has probably increased in numbers there. So the changes are quite significant, and the changes aren't just that you start to see more of these species, the distribution of them will increase across the landscape and their density will as well. to indicate what they probably were previously. And that's it, Shay.
Thank you, Tim.
And
That was
everyone else.
that was a fantastic presentation. I have to say I was very interested to note the differences between the animal tracks, how you could tell fox from a dog, and looking at like the toe placement. So I definitely learned a lot today. Thank you.
No worries.
Now, everyone, we're going to move over to question time. We have run over in terms of our presentations, but with such excellent presentations, how could we not run a little bit over time? If you're happy to all stay on the line, we will answer a question or two before we wrap this session up. So, Tim, if you could stop screen sharing, that would be fantastic.
Yep,
please.
okay. Done.
Cheers, mate. All right, so we have a question here from one of our attendees, and it is directed more to yourself, Neil. So it's about harbour removal and warren ripping. So that's fine in an open paddock or open country. What sort of options are there available in like dense native vegetation areas? Obviously, we don't want to destroy the vegetation by doing intense ripping. Have we got any other options up our sleeve?
Yes, Shay, this is often a barrier to destroying burrows, and this is where the implosion work comes in. You can implode around trees without damaging trees to any extent that would risk them being killed or even harmed. But of course, like everything, there is no black and white answer. You have to assess each site according to what it looks like. But yeah, and we recently have had a situation where somebody wanted to destroy burrows. First option is to look at the rippers. No, it's not going to work. They're too dangerous as well. So yeah, the implosion's what the landholder's going to go with.
So it sounds like we've almost got like a checklist, things that don't work, and you work your way down until you have a management tool that will work in your situation.
Absolutely right. And where there's the will, there's a way. And there's going to be a technique that will work in one way or another for whatever environment you're in.
Beautiful. Thank you, Neil. Okay, our next question, this one's for you, Tim. So we've had a little bit of interest about canid pest ejectors. Could you briefly elaborate on what CPEs are and how they work? Okay,
so very basically, it's like you imagine a small steel tube that's about 6 inches long or thereabouts. No, it's probably 5. So it's got a bolt that is spring ejected. So it's got a spring on it, and at the top, at basically ground level, you've got a food source placed around a small, very small canister. You know, it's like the end of your little finger, and in that is a powder. And what happens is that the animal tries to pull that, that's in a capsule, and foxes will grab that from the top and try and lift. That, not many native animals that can do it. Basically, it's the only one that can liberate it. The spring, that releases the spring, which releases the bolt. It hits the capsule, the capsule's contents, the powder, goes into the mouth of the animal, and it dies. Yeah.
Let me say, that was a brief, brilliant explanation. It's very hard to explain without a picture or something in front of you to actually see how they do work in their mechanisms, should I say. Thanks, Tim. And next question, John, over to you. So a lot of comments about your felixes and being an excellent innovation. So we have a question here to say, do felixes require a permit to be placed on public land or private land in other states outside Victoria?
Yeah, absolutely. So currently all felixes are used under an APVMA research permit and that's required until they get registered. We are expecting them to be registered by the APVMA within a month. They were hoping to get it done by September. There's been some delays, but there is a permit, and there will likely be permits required even after they're registered. So just like if you're deploying a canid pest ejector or putting 1080 baits out, you need to be a licensed operator, and you need to have certain signage, and there'll be a label requirement. So they'll be treated pretty much like other control tools. So you can't just put them anywhere. You need to have some sort of permit. And at the moment, any biosecurity officer can authorise some research trials in any state, except for Victoria. So if someone wanted to deploy one in New South Wales or Queensland or something, they just need their biosecurity officer to authorise the trial, and they check that it's a safe place and it's worthwhile doing, and they've got permission to go.
Thanks, John. And then I think I might just ask one last question, and Brett, this one goes to you. So after you have gone through the shooting process, what happens with the deer carcasses?
Yeah, look, we're really lucky. Our contractors are brilliant. They remove 90% of the deer carcass. They'll take all the meat, and that's 180 deer is an awful lot of deer to take meat from. So they'll leave the frame, the skeleton, and the guts, but most of the deer is taken out. So we've been really, really lucky with that. This has been a bit of a concern for people worrying about feeding foxes and wild dogs and so forth. But the project is fairly brief. So the food resource is brief. And then there's great droughts between food resource. So ultimately, it doesn't affect the population of foxes or wild dogs where we're working.
No, that's great. That's great to hear that the product is actually being utilised and not being another potential food source for our feral animals.
Absolutely.
Okay, so I know we had quite a few more questions, but unfortunately, due to the time limitations, we won't be able to address any more. So that now brings us to the conclusion of today's session. I, along with Trust for Nature, would like to extend my thanks to Brett, Neil, John and Tim for providing us with such high quality expertise-driven presentations. I would also like to extend my thanks to all the attendees today for sticking with us on this really interesting session we had today. And just a final reminder that today's session was recorded and will be available at a later date on Trust for Nature's YouTube site. Other than that, everyone have a wonderful Christmas and New Year's period, and thank you so much. See ya.
Okay. Bye.